Hello everyone. Welcome to Malaysia Online Tuition YouTube channel. In this video, we are going to be looking at A-Level Pure Mathematics 3, Differentiation and Integration Review Part 1. So if you like and enjoy watching this video, then please give us a thumbs up. If you want to receive updates on our newest video, then please hit the subscribe button as well as the notification bell so that you won't miss any of our future videos. Alright, so before we start, I would like to mention that we also offer online private tutoring for mathematics, physics, chemistry, and also biology. Okay, so for the first question here, find the exact value of, okay, so for part 1, exponential x sine x dx, okay, integration from pi over 6 until pi over 3. Whenever you get a question like this, okay, this is of course going to be integration by parts. How are we going to approach this? That's the question that we are going to answer today. So for the u and dv, okay, so always remember that you are going to use the late, okay, meaning that whatever that is on top is going to be given the priority to be differentiated. So we have log, algebra, trigo, as well as exponential. So you can see that here, the trigo will be given priority for the differentiation. So we can write sine x for the u, and dv we write e to the power of x dx. So for our du, we get cos x dx. And for our v, okay, this is just e to the power of x again. That's it. Okay, so now, when we are substituting this inside the integration by parts formula, okay, so what is the formula? uv minus integration v du. So we can write integration pi over 6 until pi over 3 of e to the power of x sine x dx equals, okay, so uv, that is going to be e to the power of x sine x. And then from pi over 6 until pi over 3, and then minus integration v du. Okay, so integration v du, that is going to be e to the power of x cos x dx from pi over 6 until pi over 3. So you can see that we have another integration by parts, okay, and we have to repeat the process. So now u is going to be cos x instead. And then dv, the same thing, e to the power of x dx. So du, we have negative sine x dx. And then for our v, we still have the same thing, which is e to the power of x. Okay. So now we can just continue from here. So we just leave this as e to the power of x sine x first. Okay, we don't have to substitute the limits yet. And then we have minus, okay, so we open a big bracket, uv, which means e to the power of x cos x, from pi over 6 until pi over 3, and then minus v du. So, but remember, you have a negative here already, so the minus will become plus. Plus integration pi over 6 until pi over 3, e to the power of x sine x dx. And surprisingly, if you look carefully, right, we have this to actually be the question that we have just now. So what you need to do here is you need to shift that later to the left-hand side. And we call this type of integration like the recurring integration, okay? Meaning recurring integration by parts, because we are not going to be having the integration by parts to end, okay? So that's why you are going to get back what you have for the question. Okay, so now we can expand the negative first. So we have e to the power of x sine x from pi over 6 until pi over 3 minus, so what is this? E to the power of x cos x pi over 6 until pi over 3, and then negative and positive, that is going to be negative pi over 6 until pi over 3 of ex sine x dx. So this thing is the one that we are going to shift to the left hand side. Okay, so shift to LHS. Okay, so after we shift to the left hand side, you know that this is 1, right? The coefficient of this integration is 1. This also, the coefficient of integration is 1. So when you shift to the left, it is going to be 2. Okay. So now we will write 2 integration pi over 6 until pi over 3 ex sine x dx equals, okay, so now we can start substituting the limits. No problem. So e to the power of x. So we have e to the power of pi over 3 sine pi over 3 minus e to the power of pi over 6 sine pi over 6, okay, close bracket, minus e to the power of pi over 3 cos pi over 3, and then minus e to the power of pi over 6 cos pi over 6. Okay. Remember, they want the exact value, right, just now? They want the exact value. So remember to give the answer in exact value, okay? So then we can shift the 2 to the right-hand side. So that's going to become 1 over 2 of everything that we have here. Okay, so sine pi over 3 is going to be sine 60 degrees. So that is going to be square root 3 over 2. So we can write square root 3 over 2 e to the power of pi over 3 minus. So what is this? Sine pi over 6, that is going to be 30 degrees. So that is going to be 1 over 2. So e to the power of pi over 6 and then over 2. Okay, and then don't close the bracket yet because the 2 integration results here is going to be divided by 2, right? So minus cos pi over 3 is going to be cos 60. So cos 60 is half. Okay, so we have e to the power of pi over 3 over 2 minus cos pi over 6 is square root 3 over 2. So minus square root 3 over 2 e to the power of pi over 6. Okay, done. Close bracket and then close the big bracket. Okay, so I think we are almost there. So remember, the problem here is we need to get the exact value, right? Okay, so we can see that square root 3 over 2 minus 1 over 2 because you have here e to the power of pi over 3, right? So what do we have here? Square root 3 minus 1 over 2 e to the power of pi over 3, okay? And then minus, here you can see we have negative 1 over 2 plus 1 over 2. Sorry, not plus 1 over 2. Negative 1 over 2 plus square root 3 over 2. Okay, so we have plus square root 3 minus 1 over 2 e to the power of pi over 6. Okay, so you can see that the square root 3 minus 1 over 2, that is the common factor. So what we can do is we can take out square root 3 minus 1 over 4. And then inside, what do we have? E to the power of pi over 3 plus e to the power of pi over 6. Okay, so we can leave the final answer like this. But before that, we have to check the answer using the calculator. Okay, so now square root 3 minus 1 over 4. And then we open bracket e to the power of pi over 3. And then plus e to the power of pi over 6. So what do we get? We get 0.8305. And then let's check the answer from the calculator, meaning the integration from the calculator. Okay, so integration ex, okay, make sure your calculator is in radian mode, okay? Ex and then sine x from pi over 6 until pi over 3. So we get the same answer, 0.8305. Okay, so we can say that this is going to be the final answer in exact value form. So that's all for the first part of question number 1. So for question part 2 here, we have to integrate 5 over x squared plus 4x minus 5 from 1 until 3. Okay, so let's do it over here. Okay, so for this question, right, we have the denominators to be actually, we can factor, okay? We can factorize, sorry, not factor. We can factorize the denominator. So what we can start with is 1 until 3 integration. 5 over, when we integrate, what do we get? X and x, 5 and 1. So this is plus, this is minus. So actually, this is a case of partial fraction integration. Okay, so the first step is for us to do the partial fraction. So we have two linear factors here. So we can say a over x minus 1 plus b over x plus 5. And then we shift this to the right hand side. 5 equals a, open bracket, x plus 5, and then plus b, open bracket, x minus 1. Okay, so we can use the elimination method. So when x equals 1, 5 equals a, 1 plus 5. So what is this? 5 equals 6a, so a equals 6 over 5. 6 over 5. 5 over 6, okay? 5 over 6. And then when our x equals negative 5, 5 equals b times negative 6. So our b is negative 5 over 6, okay? So then our partial fraction is going to be 5 over 6 and then x minus 1 there. And then minus 5 over 6 and then x plus 5. Okay, done. So now, we can continue. So the partial fraction integration is going to be 1 until 3 of 5 over 6. Okay, by the way, you can see that the 5 over 6 is a common factor for both of them, right? So you can just take it out in front. Okay, 5 over 6. And then what you have here is going to be 1 over x minus 1. And then minus 1 over x plus 5 dx. Okay, just like that. Okay, so then the 5 over 6 is still going to be in front. So when we integrate, what do we get? Ln of x minus 1 minus ln of x plus 5 from 1 until 3. Okay, so then 5 over 6. So ln of 3 minus 1, that is ln 2, minus ln 3 plus 5, that is 8. And then minus, okay, okay. That is a problem here, okay? I think I miswrote the question, okay? Just a moment. Okay, actually just now, okay, the limit cannot be from 1 until 3, okay? It can only be from 2 until 3 because if we take 1, right, then ln 0 is undefined, okay? So this is actually 2 until 3, okay? Sorry about the limits. Okay, so now 3, okay, this is still the same. Ln 2 minus ln 8. And then minus 2 minus 1, that is going to be 0. Minus ln 2 plus 5 is 7, okay? So wait, did I change all the limits? 2, yes, 2, yeah, I changed already everything. And then we can close the big bracket. Okay, and then 5 over 6. And then open bracket. Ln 2 minus negative ln 7, that is going to be plus. So ln 2 minus ln 8 plus ln 7. So what is this? 5 over 6 ln of 7 times 2 over 8. So cancel. This is 1, this is 4. So the exact value answer for this integration is going to be 5 over 6 ln of 7 over 4. So let's check the answer now, okay? All right, so 5 over 6 ln of 7 over 4. So the answer is 0.4663. So if we check the integration from the calculator, what do we get? Okay, so we take the original integration, okay, meaning before the factorization. So integration 5 over x squared plus 4x minus 5 from 2 until 3. So we get 0.4663, okay, the same with the answer that we get for the exact value form. Okay, so that's all for this question number 1, part 2. Next, for question number 2, find integration from 0 until pi over 4 of cos squared x sine 2x dx by using an appropriate substitution. Okay, so for this question, right, they didn't mention anything about the substitution that we can use. So what we can start with is, okay, we know that cos squared x, we can just leave it like that first. And then for sine 2x, we can change it to 2 sine x cos x dx. Okay, so after you get this, you know that the cos squared x we can change into 1 minus sine squared. So 0 until pi over 4, we have 1 minus sine squared x. And then you can see that everything else is going to be sine except for the cos there. Okay, so what we can do here, we can write 1 minus sine squared times 2 sine x. And then the cos x dx, we make them together. Okay, so why are we making them together like this? It's because we need to think about what is the thing that when we differentiate, we get cos x dx, okay? And definitely the answer is going to be sine x. So the substitution that we are going to be using here is u equals sine x, okay? And then du equals cos x dx, okay? As you can see here, the cos x dx is going to be du. And later, 1 minus the sine squared x is going to be u squared. The 2 sine x here is going to be 2u, okay? So what we can do now before we substitute the everything in terms of u, right? We have to find the new limits first, okay? So when x equals 0, our u equals, okay, sine 0 is 0. So when our x is pi over 4, our u equals square root 2 over 2. Okay, so now let's change everything. So 0 until square root 2 over 2 of 1 minus u squared, and then 2 sine x is 2u, and then cos x dx is going to be du. So now what do we have? 0 until square root 2 over 2. Okay, so when we expand, we get 2u minus 2u cubed du. Okay, so we integrate this. So integrating, we get u squared minus 2u power of 4 over 4, which is 1 over 2u to the power of 4, from 0 until square root 2 over 2. So now, u squared, what do we get there? Okay, so square root 2 over 2 squared minus 1 over 2 square root 2 over 2 to the power of 4. And then when you substitute 0, everything becomes 0. Okay, so square root 2 over 2, that is going to be 2 over 4 or 1 over 2 minus 1 over 2. Okay, so this is going to be 4 over 16, which is 1 over 4. So the answer is 1 over 2 minus 1 over 8, which is going to be 3 over 8. Okay, so this is the final answer that we get. But let's first check the answer using the calculator. So integration of cos x squared, okay, and then sine 2x from 0 until pi over 4. Okay, let's see whether we get 3 over 8 or not. Okay, as you can see, we get 3 over 8 for the final answer. Okay, so that's all for question number 2. Now for question number 3, find integration from 0 until pi over 4 of 3 over 5x squared plus 15 dx correct to 2 decimal places. Okay, so for this question, right, you can see that if you differentiate the denominators, you will get 10x. But the problem is you don't have x on top. So this is not going to be the integration that will give you ln. Okay, instead, what you can see that the first step that we can do for this question is we write 0 until pi over 4 integration of 3 over 5, and then you factorize out the 5, you get x squared plus 3 dx. Okay, so now what we can do is we bring the 3 over 5 outside the integration sign, and then we are going to see a familiar side here. Okay, 1 over x squared plus 3. Okay, so this is actually the integration that we are going to use the tan inverse. Okay, if you look in the MF19, okay, you have this integration result. So we can write, instead of 3, we can write x squared plus square root 3 squared, like that. Okay, so 3 over 5, and then what we can do is we can apply the integration that will give you the tan inverse. So 3 over 5, open bracket, 1 over a. Okay, so this is your a. Okay, your a here is square root 3. So the formula is going to be like 1 over a tan inverse of x over a plus c. Okay, but of course we don't have plus c because we have definite integration. We have the limits. So we can say 1 over square root 3 tan inverse of x over square root 3 from 0 until pi over 4. Okay, so now what we can do is we can take out the square root 3 as well. So 3 over 5 square root 3. And then inside, what do we have? Tan inverse of pi over 4 divide square root 3. And then when you substitute 0, it will become 0. Okay, so this is going to be 3 square root 3 over 15. Okay, I think that is going to be square root 3 over 5. Wait, 3 divide by 5 square root 3. That is going to be, yeah, square root 3 over 5. And then what's the value inside here? Okay, because they said correct to 2 decimal places, right? Tan inverse of pi over 4 divide square root 3. So what do we get here? 0.4257. So for the final answer correct to 2 decimal places, the answer is going to be 0.15. Okay, so to check our answer, don't take 2 decimal places. Okay, for the final answer, 0.14747. Okay, now let's check the answer from the calculator. Okay, so integration of 3 over 5x squared plus 15 from 0 until pi over 4. The answer is 0.14747. Okay, we have verified the answer. But since they asked for 2 decimal places, we write 0.15 for the final answer for question number 3. Moving on to question number 4, a curve has parametric equation defined by x equals t squared plus 1 over t and y equals 4t cubed. For part 1, find dy dx in terms of t. So for part 1, we can first write dx over dt. So that is equal to 2t minus, okay, so this is t to the power of -1, correct? So that is going to be minus 1 over -1 minus 1, that is -2, so over t squared. Okay, and then our dy over dt is going to be 12t squared. Okay, done. So now, for our dy dx, we are going to write dy over dt divided by dx over dt. Okay. So dy over dt is going to be 12t squared. And then dx over dt, we can rationalize the denominators. We will get 2t cubed minus 1 over t squared. Okay, like this. So you can bring the t squared up like that. So that is going to be 12t to the power of 4 over 2t cubed minus 1 for our dy dx. Okay. So this is the final answer for the first part, which is dy dx in terms of t. Next, for part 2, given that t equals 3, find the equation of the normal to this curve. So when they give the value of t to be equal to 3, we can first find what is the gradient of tangent first, okay? So when t equals 3, the gradient of tangent, okay, meaning our dy dx changes to mt, okay, or gradient of tangent, equals 12, and then 3 to the power of 4 over 2, 3 to the power of 3 minus 1. So what is this? So 12 times 3 to the power of 4 divided by 3 cubed is 27, 54 minus 1. So we get 972 over 53. Okay. So then for the gradient of the normal to this curve, we get mn to be equal to negative 1 over this. So 972 over 53. Okay, so we get negative 53 over 972. Okay, done. So then, before we can find the equation of the normal, we need to first find what is the x and y coordinates, okay, for us to use with the normal to this curve. So for x, we get 3 squared plus 1 over 3. So this is 9 plus 1 over 3. So x equals 28 over 3. And then for our y, 4 and then 3 to the power of 3. So what is this? 27, right? Times 4, that is 108, I think. 27 times 4 is 108. Okay, done. So now we can use the x and y coordinates that we get. So we can use y minus 108 equals the gradient, negative 53 over 972. And then x minus 28 over 3. Okay, done. So y equals negative 53 over 972x. Okay, and then we just use the calculator, okay? So negative 53 over 972 times 28 over 3. Okay, and then plus 108. Okay, so what do we get? Okay, we get something which is not defined by fractions anymore. Okay, so we can just leave our answer plus 107. Okay, so this is the equation of the normal to this curve when our t equals 3. Okay, so this is the final answer for question number 4, part 2. Okay, now for question number 5, which is the final question of this video. The equation of a curve is given by x cubed minus 12xy squared plus 2y cubed equals 14. For part 1, find dy over dx. So, if you look at the equation of this curve, to get the dy over dx, we need to differentiate implicitly. Okay, so differentiating implicitly, for x cubed, we get 3x squared dx over dx, so we don't have to write that. Minus, if we differentiate the x, we get 1, so leaving us with only negative 12y squared dx over dx again. And then if we differentiate y squared, we get 2y, so negative 12 times 2, that is negative 24. So minus 24 xy, and then don't forget dy over dx. And then plus 2y cubed, you differentiate, you get 6y squared dy over dx, and then equals 0. Done. So we can factorize out the dy over dx. So dy over dx. And then you can see that besides the dy dx, what we can take outside is going to be the 6y, okay? And then leaving us inside y minus 4x only, okay? Equals, we can shift the 3x squared minus 12y squared to the right hand side. So we get 12y squared minus 3x squared. Done. Okay, and then our dy over dx is going to be, so we can take out 3 for the numerator. So 3 open bracket 4y squared minus x squared. and then divided by, we have 6y, open bracket y minus 4x. Okay, done. So we can cancel the 3 and 6. So this is 1, this is 2. So our dy over dx is going to be 4y squared minus x squared over 2y, and then y minus 4x. Okay. So this is the final answer for the dy dx, and that's all for part 1 of this question number 5. And then for part 2, find the exact coordinates of the stationary points on the curve. So for stationary points, we know that our dy over dx must be equal to 0. So then the numerator, which is the 4y squared minus x squared, must be equal to 0. So we can see that x squared equals 4y squared. So our x is going to be plus minus 2y, okay? Because square root of 4, that is 2, square root of y squared, that is y. Don't forget the plus minus, okay? So we can see that we have more than one stationary point, right? Because you can see the exact coordinates of the stationary points on the curve. So we can start with x equals 2y. So when x equals 2y, we can substitute. So 2y to the power of 3 minus 12, and then 2y, and then we have y squared, and then plus 2y cubed equals 14. So 8y cubed minus 24y squared plus, not y squared, y cubed. Okay, because y squared times y, that is y cubed, plus 2y cubed equals 14. So 10 minus 24, that is negative 14y cubed equals 14. And then you can see that y cubed equals negative 1. So the value of y here is going to be cube root of negative 1, which is just negative 1. And then for the x coordinate, you have 2 times negative 1, which is negative 2. So we found the first stationary point on the curve. So for the next stationary point, when x equals negative 2y, so we do the same thing. So negative 2y and then cube minus 12 and then negative 2y and then y squared and then plus 2y cubed equals 14. All right, so let's pen a bit. Okay, so negative 8y cubed plus 24y cubed plus 2y cubed equals 14. So negative 8 plus 24, that is 16. 16 plus 2, that is 18. So 18y cubed equals 14. Y cubed is going to be 14 over 18, which is 7 over 9. So for the y coordinate, that is going to be cube root of 7 over 9. Okay, so then what is the x coordinate? Negative 2 of what you have just now, cube root of 7 over 9. So then our x is negative 2 cube root of 7 over 9. So for the final answer for the exact coordinates of the stationary points, we have negative 2, negative 1, and then we write negative 2 cube root of 7 over 9, and then cube root of 7 over 9. Okay, so that's all for this question, number 5, part 2. And that's all for this paper, that's all for this differentiation and integration review, part 1. So if you have any question or any comment, please leave them in the comment section below. So if you like and enjoy watching this video, then please give us a thumbs up. If you want to receive updates on our newest video, then please hit the subscribe button as well as the notification bell so that you won't miss any of our future videos. Thank you very much for watching this video, and finally, please take care, and I hope to see you in our future videos.